Day 59 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Another day, another LeetCode problem. This time we're at day 59. I hope you guys are feeling good. I hope you're well rested. I hope you guys aren't feeling even the slightest bit of burnout because we're still going. So I hope you guys are still motivated and excited about this problem we have here today. But before we get to the problem, don't forget, guys. Don't forget, guys. Go ahead, bring a mouse right over here. Right over here and click that subscribe button for me, guys. Then after you click that subscribe button, go ahead and smash that like button for me. Then after you smash that like button, go ahead and drop that bank emoji in the comments. I need all of my bankers out there to go ahead and drop a bank emoji in the comments so we can run this engagement up and run this Swift community up and bring more awareness to Swift and the Swift community as a whole. Now, guys, with that being said, the part you've all been waiting for, the main event, the main attraction, the question we have here today is question number 1466, reorder routes to make all paths lead to city 0. The difficulty level is medium, but you guys already know we're not going to let that stop us. We're still going to keep the solution as easy and simple as possible, guys. So, let's see what the question says. It says there are n cities numbered from 0 to n-1 and n-1 roads such that there's only one way to travel between two different cities. This network forms a tree. Last year, the Ministry of Transport decided to orient the roads in one direction because the roads are too narrow. Roads are represented by connections where connection I is equal to AI, BI represents a road from city AI to city BI. This year, there will be a big event in the capital city 0, and many people want to travel to the city. Your task consists of reorienting some roads such that each city can visit the city 0, return the minimum number of edges changed. It's guaranteed that each city can reach 0 after reorder. So, let's break that down and see what they're talking about. So first we have an example. We have an input of n equals 6. Connections equals an array of arrays, a 2D array of the different nodes and the different nodes basically and where they connect to. Then the output is 3. Explanation: change the direction of edges shown in red such that each node can reach the node 0 capital. So let's break this down to see what it is. So we want to get here. We need all roads to lead here to 0. All roads must lead to 0. The roads in black, or the edges in black, the edges represent the roads. So the roads are the original nodes. The edges in black are the original edges or the original roads. So if we look at 0 to 1, we see that we have a road going from 0 to 1. However, we need the roads to lead to 0, not go away from 0. And this first edge right here is going away from 0. So that's one node we need to change. That's why it's a red one changed right here, right? So we need road 1 to lead to 0, and we need road 4 to lead to 0. However, road 4 already leads to 0, so we don't need to change that. So now we realize we need to change road 1 and turn it around so that 1 leads to 0, right? So now that we changed that one, we have to check the neighbors. Let's check the other neighbors. Let's check the neighbors, the 1 going to 3 and 4 to 5. If you look, 1 is going to 3, but so we need to change that one too, because we need 3 to go to 1 so that 1 can go to 0, right? Because all roads must lead to 0. And right now, 1 going to 3 is messing up our roads, our map or our directions. We're trying to go the opposite direction. So that's another road we need to change, or edge. So we need to change 3 to 1. Then we look at the neighbor for 3, the other neighbor 2. 2 is already going to 3, so we don't need to change that. And we already changed this one, so 3 goes to 1. And then we already changed this one, so 1 goes to 3. Now we need to check 4's neighbor, 4 and 5. 4 edge leads to 5, or the 4 row leads to 5, but that's not what we wanted to do. That's going the wrong direction, so we need to change that around. So 5 goes to 4. So then when we change that around, 5 goes to 4, 4 goes to 0. So this whole path leads to 0. Then we change 1, so 1 leads to 0, and we change 3, so 3 leads to 1. We didn't need to change anything about 2 leading to 0. So after we change these two edges or these two roads, this whole path leads to 0, which is what we want. So let's break this down right here so we can understand what this is saying as well. So we don't have to always look at the picture. So if you look right here, we have 0. 0 goes to 1. We need to change that. That lets us know it goes 0, then it goes 1. That lets us know 0 goes to 1. Then we look here, it goes 1, then it goes 3. That lets us know 1 goes to 3. But when we look here, it goes 2, 3, which is this. So that lets us know that 2 goes to 3, right? Because it goes 2, then 3. So that means 2 goes to 3, and that's what the picture shows. And then come down here, it says 4 goes to 0. And that's right, 4 goes to 0 because 4 is first in this line, or 4 is first in this array. So that lets us know 4 goes to 0. It goes 4 then 0. So that lets us know it goes 4 then 0. Then we look here, it goes 4 then 5. So that lets us know it goes 4 then 5. And that lets us know we need to change this because we need all paths to go to 0. So really we need this to change to 5 to 4. We need this to change to 3 to 1 instead of 1 to 3, and we need this to change to 1 to 0 instead of 0 to 1. So I hope that makes sense to you guys. That's just how the list works without using the pictures. So let's look at example 2. It's the same thing really, but it's a different example. So we're going to look at it just in case. We have n equals 5. The connection equals the list of nodes and edges that we need or that we are given, and the output is 2. Oh yeah, guys, remember that. We didn't go over the output up here. The output is 3 because there were 3 edges or 3 rows that we need to change. So just remember that we don't need to necessarily change the edges. We just need to count the edges that need to be changed. So just keep that in mind. We don't actually need to change them. I said we need to change them up here. That's just so you could understand what's going on. But really, we just need to count the number of edges or rows that needs to be changed. Now let's look at example 2. Example 2, so we have the same thing, the list of rows and edges or nodes and edges. The output is 2 because there are 2 edges that need to be changed, 1 and 2. So if you look, let's look and see what it has. We have 1 goes to 0. That's right, 1 goes to 0. Then we have 1 goes to 2. 1 goes to 2. That's the black edge, but that's not right because we need to change that to 2 goes to 1. So it would be 2 comma 1 instead of 1 comma 2. Then we come over here and we check it goes 3 goes to 2. So that's right, 3 that goes to 2. Boom. Then we need to check this. This one says 3 goes to 4. 3 goes to 4. Okay, no, we need to change that. So now, so that it goes 4 goes to 3 this way. So that's another edge that we need to change. And remember, we're just counting the edges that need or rows that need to be changed. We don't actually have to change them. So the count is 2 because there are 2 edges or rows that need to be changed. That's why the output is 2. Explanation says change the direction of edges shown in red. Change the direction of edges shown in red such that each node can reach the node 0, which is the capital. Then up here we have the input n equals 3. Connections, we have the same thing. The output is 0 because 1 goes to 0. It shows 1 goes to 0 and 2 goes to 0. So that we don't need to change anything. That's why the output is 0. So now that you guys understand the question, let's see how we are going to code this because that's the exciting part. That's the part that we are all here for. So with that being said, let's see, guys. So first thing we need to do is we are going to create a helper function, right? So first thing we're going to do, we're going to say func, and we are going to call this, what do we want to call this? We could call this DFS. So we'll just for depth of first search. So we'll call this helper function DFS, and it's going to have a node, which is going to be an integer. Excuse me, guys. Node is going to be an integer. It's also going to have the parent, which is going to represent the parent node, which is also going to be an integer. Then it's going to have the adjacent, which is going to represent the edges and stuff. So this is going to be a 2D array of tuples, and we're going to say we're going to put two arrays, and then we're going to put the parentheses inside those two arrays to represent the tuples, and it's going to be an integer and another integer. Then we are going to come down here. Oh, excuse me, guys. We got to put the colon. Then we're going to come over here, and we are going to say for neighbor, comma sign, which is going to represent the edge. So we're going to have the neighbor, which is going to represent the neighboring node, and we're going to have the sign, which represents the edge, and we are going to say n adj node. Then we are going to say, we are going to open up the brackets, and we are going to say if neighbor does not equal parent, we are going to come down here and we're going to say count plus equals sign. Then we're going to come down here, do some recursion. It's DFS neighbor, comma node, comma adj. And that's all we're going to write for the helper function, guys. Then we're going to come up here. First thing we're going to do, we declare a variable called count, and this is going to keep count of all the edges or rows that we need to change. And we are going to come right here, and we are going to say, first we're going to declare another adj, and we are going to set that equal to, it's the same thing, a 2D array of tuples. So we're going to put the two array brackets, then we're going to open up the parentheses inside of those array brackets, and we are going to put an integer and an integer. Then we're going to say repeating, then it's going to be an empty list of count n. Then we're going to come down here and we are going to say for connection and connections, we are going to say adj, and we are going to say connection 0. I'll put that in the array brackets, put the 0 in the array brackets. Then we're going to say append. Then we're going to append connection 1, comma 1. Then we are going to, hold on, guys. Let's start over. Let's do this line over. We're going to say append, then open up the parentheses. Then we're going to open up some more parentheses, and we're going to say connection 1, or open the array brackets and put the 1. Then we're going to say comma 1 without the array brackets. Then we're going to come down here. We're going to do the same thing. We'll say adj. This time we're going to say connection 1, and we are going to append, then open up the parentheses, then open up the parentheses again, and we're going to say connection 0. Then we're going to say come outside of this brackets and say comma 0. Then after that, we're going to come down here and we're going to call DFS, and we're going to enter 0, comma -1, comma adj, and then we are going to come down here and we're going to return count, guys. And that's all she wrote for today. Let's run it and see what happens. Boom, and it's accepted. So let's submit it and see what the time is looking like. Hopefully it's a good runtime today, guys. Ooh, I like it. 549 milliseconds beats 93.51% of users with Swift, guys. So here, get the code one more time. If you ain't got it, get it one more time. We got the count. Boom, boom, boom. And until tomorrow, guys, I'll see you then for another day, another LeetCode problem.